In this video, we are going to learn about classifying real numbers. Let's begin. Over the summer, Ethan spent a week at an overnight camp. He ended up meeting tons of friends, and some ended up being people that he goes to school with this year. On the first day of school, he recognized one of his camp friends in his math class. Other friends that he met at camp live in different states, but they still keep in touch throughout the year. Task 1. In no particular order, the headings below describe the different types of friends that Ethan met at camp. Using the graphic organizer below, see if you can place each of the headings in the box where they belong. So we have a giant box, and this box is the friends from camp box. And we have a bunch of smaller boxes and boxes inside of boxes, and we have like this kind of side box over here. So these are this large box is the category of friends from camp. Now, they want us to put these other headings. Same state, same class, out of state, same city, same school. Some of these categories are really big categories, and some of these categories are really small categories. So think about it. Which one of these is the biggest category? Well, out of state or same state, those are pretty big categories. It's actually probably better to think about this in terms, if you want to categorize this, to think of which one is the smallest category. So same state, state's pretty big. Same class, pretty small. Out of state, big. City, small. Same school, small. But of these categories, city, school, class, which one's the smallest? Well, same class. Think of all of these. Same class is the smallest. Say class. Or same class. After that, so we cross that off. Which one is the next biggest category? I would say same city, same school, same state. Well, it's going to be same school. So class, school, and then after school, it looks like we have city. And what's bigger than a city is we've got state and out of state. Well, it looks like this category would be the same state, because if it's out of state, well then out of state wouldn't be the same city or same school or same class. So same state and in this other box we have out of state. And something you'll want to notice, this box right here, this middle or the smallest box, if his friends are in the same class, that means they're also going to be in the same school, which means they're also going to be in the same city, which means they're also going to be in the same state. Now, if they're out of state, is it possible for them to be in the same class or school or city or state? No, not at all. Out of state is kind of on its own thing on the side, but if you're in the same school, you could be in the same class, but not necessarily. If you're in the same school, but not in the same class, you're still going to be in the same city, same state. If you're in the same city, you're still going to be in the same state, but not necessarily the same school or class. So these categories get bigger and bigger and bigger and bigger, but all of them are friends from camp. So this illustration is, well, before we get to what this illustration has to do with, let's answer the questions below. Is it possible for a friend in the same class to go to a different school? So is it possible for a friend from this same class to go to a different school? Well, no. If you think of your friends in math class, is it possible they go to a different school? No, they would be going to the same school as you. So the answer is no. I'm just going to put an N. Next, is it possible for a friend in the same state to go to a different school? So same state. So let's say you live in California. Is it possible for your California friend to go to a different school as you? It is. So the answer is yes. Ryan is one of Ethan's camp friends who is also in his first period class. Write Ryan's name in all the boxes where he would be included. Is it necessary to write Ryan's name in more than one box? Well, let's see. Ryan. Yeah, and it asks us to write his name in all the boxes where it's included. So Ryan's in the same school, Ryan's in the same state, and Ryan is also a friend from camp. So is it really necessary to write his name in all these boxes? I would say no, because if he's in the same class, then he's also in the same school box, the same city box, the same state box, and also the friends from camp box. So if he's in the middle, he's in all the boxes already except for the out-of-state box. If he's in the school box, because he only goes to the same school but has no same classes as him, well, then that means he's in the same school, city, state, and friends from camp box, but not in the class box. So the answer is no, not necessary. What does this have to do with? Well, this has to do with organizing numbers, classifying different numbers. We have many different numbers, and they fall under different categories, such as rational and irrational. We're going to add more categories. So we're going to read through the types of real numbers in the table below and give a few examples of each. Now, all the numbers we're dealing with are called real numbers. Are there other numbers besides real numbers? Well, technically there's something called imaginary numbers, but we're not going to touch on those now. So let's look at the set of all positive counting numbers, numbers on a number line, starting with 1. That is natural numbers. So natural numbers start with 1, and it's all positive counting numbers. What are counting numbers? Like 1, 2, 3, 4, 5, 6, ... All right, next we are talking about whole numbers, and whole numbers are the set of all positive counting numbers starting with 0. Kind of silly that we have two different categories, but sure. So whole numbers are 0, 1, 2, 3, 4, 5, 6, ... So what's the difference between natural numbers and whole numbers? Well, whole numbers include 0, natural numbers don't include 0. So if you're a natural number, like 3, then you're also going to be a whole number, because it's in both of them. All right, integers. What are integers? Integers are the set of whole numbers and their opposites. What's an opposite again? Well, the opposite of 2 would be -2, right? So it's all the whole numbers, it's all of these numbers, 0, 1, 2, 3, 4, 5, 6, plus their opposites. So that would be like -3, -2, -1, 0, 1, 2, 3, ... and going in the other direction as well. So integers are basically whole numbers and their opposites, which are also negative. Rational numbers, they are numbers that can be written as fractions. They are terminating decimals, repeating decimals, and perfect squares. Because perfect squares, like the square root of 81, or the square root of 100, which is, square root of 81 is 9, and the square root of 100 is 10. Those are whole numbers, so that's why they'd be rational. So what are rational numbers? 1/3 is a rational number. Let's see, they talk about terminating decimals. How about 3.21? That's a terminating decimal. They talk about repeating decimals. How about 1.3 repeating? They talk about perfect squares. Well, perfect squares, that equals, that would be perfect squares like square root of 4, which is 2. So rational numbers are a very big category. They include all of the integers, all of the whole numbers, and all the natural numbers. Finally, irrational numbers. These are numbers that cannot be written as fractions. And they are non-terminating decimals, non-repeating decimals, and imperfect squares, or non-perfect squares, or imperfect squares. So non-terminating, let's start off with that one. How about 3.12493 ... It just kind of keeps going. Pi is a very famous irrational number. You also have imperfect squares like, 11. What times what equals 11? Well, it's hard to think of it because it's a weird imperfect square. It's got a decimal that goes on forever that doesn't repeat.